Before we proceed to draw the ray diagrams, there are several terms that you need to remember. With reference to the diagrams that is shown on the right, the first point that you need to know is called the optical center of the lens. Now, where is this optical center? This is a point where any light ray will pass through without any bending or deviation. As shown, this black dot here is the optical center. The next point you need to know is called the principal axis. It is an imaginary line that is drawn cutting through the center of the lens. The third point is called the focal point, which is the same distance away from the center of the lens to the left and right of the lens, denoted by f primed and f. This is a point on the principal axis where the light rays that are parallel will converge and meet after they pass through the converging lens. And then you also need to know the meaning of focal length. Essentially is a distance from the center of the lens to the focal points on both sides of the lens, denoted by this small letter f. So these are the four terms that you need to know, and we can now proceed to look at two practice questions. Practice question 1. You have an object of height 5 cm is placed 15 cm in front of a converging lens of focal length 10 cm. Using scale drawing, determine the image distance and the size of the image with a scale of 1 cm to 5 cm. So let's see how we draw the ray diagrams. Scale 1 cm to 5 cm. First of all, we draw the principal axis. Next, we insert in the converging lens. Next step, we put in the focal point, f1 and f2. Then we have the upright red color arrow shown on the screen. This is the object, so I call it O. Then we can now proceed to draw the rays. First ray will start usually from the tip of the object, parallel to the principal axis, and once you touch the center of the lens, you will deviate down and cut through point f2 on the other side of the lens. So this is the first ray. The second ray will start from the tip of the object, and it will pass through the optical center without any deviation and will intersect the first ray, usually at one point on the other side of the lens. So this point is the point where the image of the object will be. So we can also now draw the image on the right side of the lens, indicated by the inverted red color arrow, and I label this as the image I. Conclusion we can come out from here is that the image distance is 30 cm and the image height is 10 cm. These numbers are obtained by using actual measurement. You can try this on a piece of paper. You should be more or less getting the same number. And to describe the image is inverted, they are real, and of course enlarged, because the image is obviously a larger size than the object. One more point to take note is that you only need 2 light rays, which will be sufficient to locate the image. You don't need 3. Now let's take a look at practice question 2. A small object of height 4 cm is placed 5 cm away from a thin converging lens where the focal length is 10 cm. Use a suitable ray diagrams. Find the characteristics, position, and size of the image. So, scale 1 cm is to 2 cm. Now, sometimes the questions give you the scale. If the question doesn't give you the scale, you got to decide on your own what scales to use. Again, you have the principal axis and the converging lens. 2 focal points, 1 on each side of the lens, and now we have the object O between the center of the lens and the first focal point. We will proceed with the same procedure. First ray drawn parallel to the principal axis, deviate and cut through the focal point F2. Second ray from the tip of the object, cutting through the center of the lens, going straight down. Now notice what happened is that at this situation here, the two rays on the right side of the lens do not converge. What does it mean? Now this simply means that there will not be any real image formed to the right side of the lens. So where exactly is the image? What we can do now is that we can do a backtracking of the rays. Notice the two yellow color dotted lines that I actually used to backtrack from the two rays. At this position where the two dotted lines intersect is where the image exactly is, and indicated by the dotted line upright arrow to represent an image form due to these two rays which are dotted lines. Now the lines are dotted because they are not real light rays, they are virtual light rays. So virtual light rays will obviously produce virtual image. So this image is actually a virtual image indicated by dotted lines as well. So you're going to describe the image. The image is upright, virtual, and enlarged. It is 10 cm from the lens and on the same side as the object. So this 10 cm you can obtain using physical measurement. Try this on a piece of paper. And the image height is 8 cm. Same thing, this value can be obtained by physical measurement. And remember dotted lines, they will be for virtual image. Thank you for your attention. This is the end of the video.